Good morning, ladies and gentlemen. Um, I had a great introduction from Andy. I don't really need to talk much more about myself. Um, I'm here because last year my US colleagues asked me to write a paper for a SNAME conference. And I wanted to dig a little bit deeper than some of the things that are normally said about things like the digital twin. Oh, that's a good button. I think the challenge with a lot of the presentations early in the conference is that they can be quite scary. There's lots of big words, lots of great diagrams. We've talked a lot about digitization, but how do I get into it? It can seem quite scary. But the scary thing is that we're already dealing with it. I'm quite surprised that in our adverts on the UK television, we've already got ones on the digital twin itself. It's not called the digital twin, but we've got financial companies selling their credit information through an equivalent of the digital twin. We have Dan and Dan's data mirror. But even so, we've got the Industry 4.0. It's generally a big diagram with lots of scary words. I mean, as an engineer myself, I feel, how can I get into this? This seems to be quite difficult to get into, so complicated. And I thought, well, how do I deal with this stuff in my normal life? I'm a home worker. I work in an office. I'm capable of cycling to my customers. Cycling is normally quite a simple activity. Well, it is when you start. But then you want to know a little bit more information. So you want to know your speed. You put a small device. You want to know how quick you're cycling. Okay. You upload all that information when you're going along to a small computer. It's not the size of a laptop. It's just a tiny device. It's very affordable. So I'm cycling quite a lot. I tend to get into a little bit more. If I go training, I want to know how fast my heart's going. I wear out my bike, I buy a new bike. Strange idea, someone came up with the idea that you have electric to power your gears. It seems a surprising idea, but actually it's quite nice if you experience it. You can go on with the training to understand how much effort you're putting into your pedals. So my cycling experience when I'm going training is quite digitized, I would say. You take that further at the end of your ride, upload all your data to a mobile phone, that sends it up to a cloud. You can share that on social media, see where you're going. Something that I'm still not yet used to is the idea of using my mobile phone to upgrade the software on my bike. This is a very strange experience when you're doing this in your garden. We can see that this is now getting quite an interesting experience. But over time, I can use this platform to monitor my training. I can see how well my cycling performance is doing over the years. My experience is becoming quite digitized, but I've not yet worked out where the digital twin came in until a few weeks ago. Presently, I'm training for quite a big cycling event in the Alps. I live in a flat area. I live near the sea. I'm going to be experiencing what air is like at 2,600 meters. I've never been there before. But I can experience that in a virtual simulation. The simulation can allow me to feel what the resistance is like pedaling up a mountain for 2 hours. I'm not necessarily looking forward to this experience, but there's a reason why I'm doing it. And this is demonstrated by one of my cycling friends. This is how I want to feel like when I get to the top of the mountain. I'm not training for great performance, but I'm training for an economical experience. I want to take a selfie on the top of the mountain. Everybody else can be suffering down below, but I want to be happy. And this is kind of no different to some of our projects. When we're in business or doing complicated engineering, we want to be perhaps feeling like that when you've finished your project. Because you know that tomorrow you've got to start another project. If you're dying when you get to the top of the hill, you're not ready to start your next project. So let's move on to the digital twin. The presentation is kind of broken down into two parts. I first need to talk a little bit about the organizational aspect, the information itself. But what I'm more interested in is the digital twin as a philosophy. And as you saw in some of the earlier presentations, I think it's an opportunity to make our projects more efficient, to achieve more. So let's start by talking a little bit about the need, and surprisingly, some of these things already came up in the presentations this morning. We, of course, have increasing environmental standards, safety standards. We want our vessels to be better economical performers. But these things have always been the case, forever, in shipbuilding and ship operation. But in modern times, we're seeing an increasing use of technology to achieve this. And in particular, we're seeing a lot of repurposing of consumer technology in a lot of the areas. At the same time, something that was also mentioned, that we're seeing a decrease of hands-on skills in the workforce. The skilled hands-on workers are getting older, they're starting to retire, and because they're not necessarily transferring their skills, it's very difficult for those to get the opportunities to learn those skills. But the younger generation is finding different ways to get around that. They're using a lot more digital technology, a lot more simulation technology. So how can issues in the world affect us, particularly around ships? A simple case, a breakdown on a ferry, passenger ferry, leads to some unhappy passengers. Perhaps you have to pay some compensation. But at the end of the day, nothing goes wrong. It's just a technical problem, as they would say on the website. It can be more severe. Last year, British Airways suffered a complete systems outage in their data center. I believe it was off for 3 days. Allegedly, this was down to an IT worker switching the wrong switch. Much like the simple solution like this, maybe a flippant remark would be to have a little sign saying, maybe do not turn off the switch. I assume it must have been more complicated than this. A greater reason for the systems to take longer to be turned on is that they followed the wrong procedures. At the time, it was reported that the losses were 80 million, and a couple of days later, 120 million pounds due to compensation. So these little things can have very big effects. This example is perhaps another one where this kind of solution again comes in, but this is from 30 years ago. This is a water treatment plant where my parents live. There was a case where a delivery driver was running late. It was so late that the people in the water treatment plant had gone home. And he was doing a delivery of aluminium sulfate. He delivered it into the wrong tank. He delivered it into the public water supply. Now, this is a poisonous material. It affected the whole town. But he was left a note to deliver it to a tank on the left, and he went into the wrong one. The effects on this on the population were quite large, but in time terms, it took 25 years to investigate and generate the reports. Over that period, it was attributed that there might have been 2 deaths relating to this poisoning incident. So a little mistake can be very severe. Again, simple solutions could really help with this. Maybe we could have put some information on a mobile phone. We think that today we wouldn't have such incidents, but only last month, a delivery to a fuel station in Reading managed to mix up diesel and petrol. They pumped 9,000 litres of petrol into the heavy goods vehicles before they realised that this mistake was there. So simple things potentially need thinking about so we can solve them. Returning to the marine area, an interesting report at the beginning of the year from the mutual insurer Swedish Club is they found that 55% of auxiliary engine casualties are happening within 10% of the time between overhaul. So they're attributing this that a lot of the failures are caused by issues with the maintenance process. They're highlighting that often these maintenance activities are being carried out by the crew of the ship. Perhaps they're experiencing ever complicated marine diesels. But they point out that the average repair cost is coming in at $345,000. Looking at this could save quite a lot of money. So maybe that's down to better training material for the crew, better information, or perhaps we could start looking at changing the design of the ship operation to accommodate better specialized crew, or time in port where specialized crew or service engineers could come on board. So it's about thinking outside of the box. Now, traditionally, when AVEVA's talked about the older ways of information, we've highlighted it as a pile of paper, being difficult to find information in this area. But in the modern world, we have perhaps something that's very similar, information sitting in black boxes somewhere in the world, information in email, information in folders that take a long time to find. So have we yet generated a good way of finding our information? The digital twin is often being illustrated as some graphical image, a 3D model, but we don't always have 3D models for our assets. So I think we need to think a little bit deeper about what the digital twin is, how we want to access the information, how we are accessing information now. In our professional lives, we look for our colleagues. We look to training, formal knowledge sessions like this. We go to systems, look at documentation. We go to peer-reviewed publications. Yet in our personal lives, we'll quite happily go and ask Google. We'll go to YouTube to understand how to replace a battery in a mobile phone without any formal training. We'll use social media to ask questions. Sometimes there's specialist social media out there. We'll also ask our friends. So there's a complete mismatch in these two areas. In our business lives, we use qualified information that's highly contextual, but we often have poor accessibility and poor integration of information. And then we go home, we'll quite happily consume unqualified information. We might take a bit of time to find it, but we can find it very quickly because often our homes have better connections than our businesses. So it's quite surprising how we're dealing with these two areas at the moment. Another challenge that comes from running businesses, particularly in the marine world, is that our assets last a long time. So software, data formats become legacy very quickly. New technology is always bringing in those continuous changes. The workforce skill sets are changing over time. And we are applying bigger business expectations and resources are getting more scarce. IT is always evolving faster. Against that, as humans, we are resistant to these changes, especially when the change is revolutionary. We don't know how to cost these IT solutions, especially when there are effects that we cannot really see. It's easy to cost software, the hardware, but how does it affect the people itself? In this respect, we're very risk averse. If it kind of works, why change? So this is what makes a big resistance to some of these kind of digitalization changes. And if we want to experiment, what we're looking for is really a non-disruptive approach to kind of investigate these things rather than destroy some of the nice process that we already have working very effectively for us. I believe that some of the software that AVEVA has can actually do this. And breaking this down, I feel that the two areas in the way it does this is through an idea of context and content, using these kind of words to build a foundation for you. Let me explain that. When I was at university, I worked in a boatyard. I was laying a deck, and we were using some specialist nails. They're called grip-fast nails. They're made of copper. They don't rust. During the laying of this deck, we ran out of the nails. And although it was probably 20 years ago now, Google did exist. So I typed in copper nails. The only answer I got back were for copper nails. It seems that at that point in time, hardware stores were not really on the internet, so I couldn't buy nails from the internet. Surprisingly, when you do this now, you only get the copper nails that I wanted then. Whether Google knows something about me, I don't know. It's a scary idea. So this idea of context is powerful. Let's take this example of the digital twin image we had earlier. We have a pump in an engine room. This pump is tagged. It has a name that we all understand. So we can see that probably from the format of that name, it's a pump. We can see from the acronyms used in that it's from a SW system. That could be saltwater or seawater. We can see from its location, it's in the main engine room. So based on that item being there, it has a lot of context that we can go and investigate, and we can take those into the documentation around it. We can build a lot of links. We could also consider these to be hyperlinks of a web page if we wanted to. So what's important in this image is really not necessarily the graphical picture. It's the links between the information. At a simple level, this could be stored in something as basic as a text file. Perhaps not very effective for a big organization, but you can go really simple. Of course, we're engineers. We like to make it more complicated. We'll turn it into something that looks like this. This is more powerful because it gives us a little bit more contextual information. And it helps us build up some of the things that, for example, are in AVEVA Net. So we see here what's effectively a product model tree. But in AVEVA Net, this is built dynamically from a set of rules. The advantage of that is that for your colleague who might have a different role in that project, he can see a different kind of tree. It's just dependent on the rules that are set up. So this can be very flexible. You're not having to hard code this into the system. You can adapt it and adapt it over time to your own needs. So taking a tour quickly through AVEVA Net, this is potentially a home page for a pump. We can see the product model tree on the right there. And if, for example, we want to have a look at a diagram, you click on the hyperlink, and it takes you to a diagram. You actually see this out in AVEVA Engage in the lobby there. But you can also go to other areas. We can look at other things on the home page. We have a 3D model of that item. We see the 2D documentation. Dig into the documentation. You can learn about performance parameters, maintenance information. On the 3D model side, you could go in and quickly have a look about any maintenance implications, say, items that need to be removed. So AVEVA Net is bringing all the contextual information and giving you the content that's relevant at that time. You're not going to have to search for that information. And it's not having to change any of the systems that this information is stored in. So when you zoom out, you have a very similar view that we had previously of lots of links of contextual information. For a lot of kind of ship operators that I worked with when I was a naval architect, this could have been a problem because there wasn't necessarily so much digital information around, but we can still solve that. I mean, we can scan in paper documents, use optical character recognition to extract the text. We've all got mobile phones. There is, in fact, nothing stopping you from going out and creating a digital twin with a mobile phone, just taking photographs. It could be done fairly easily. But you could go more high-tech, take a laser scan. This is of a ship that was built in 1940. There is definitely no digital information on this vessel until you start capturing it. Why do you need a complicated digital model? Every ship has a stability model. Why not use that? That could be exercised. It's just a question of innovating with the information you have available. And all of that information can be distilled into HTML files, which is ultimately how that information gets to your screen, whether it's on a mobile phone, on a desktop. Many of the younger members in the audience have probably written HTML, or you could just go out and get a graduate or your children to do this for you. I mean, it is become a normal thing. Word, you can write an HTML document with Word. So you can project information onto a lot of mobile technology and give yourself some information at the time when you need it. So this has been much discussion about the implementation. I think what I'm more interested in this respect is a lot about the philosophy of the digital twin. And much like I think the statement earlier is that the fire is not necessarily the master. I can't remember what the statement was, but it's the first time I've heard it. But this is where you need to take control of the digital twin and make it work for you, not be a slave to it. So taking control, what is this actually about? Well, it means that you are in control of your information. You understand what is relevant, what is qualified, and what is valuable to you. Give yourself the ability to get rid of that information that's not relevant if you don't need it. The digital twin can actually help you do this. It can optimize this process by connecting information together using those contexts. It can expose any inconsistencies when contexts don't match. It can improve the accessibility to find stuff. It gives you the ability to create insight. We can use this information throughout the ship lifecycle. We're always creating information. In the initial stages, we use our information systems, the CAD, the materials management, for example, to build up a massive amount of information. This isn't necessarily transferred on to the operational phase. A lot of that works through individual documents, drawings, and emails. It's a different kind of experience. Throughout the different operators, the amount of information may change. Not everything gets handed over. And I don't know if you've ever had the ability to work for a ship that's near the end of life, when you have plans that are photocopies of photocopies, you're not really sure of anything. It gets really challenging. Imagine what a digital twin could do. I remember my colleagues, after a 9-month project, going to the dry dock where the modifications were being made to a ship, and going into the dry dock and seeing that the lines plan that they had was not the lines plan of the ship that was in the dry dock, and going, we've got some work to do. It's a scary process down that end of the market. AVEVA has traditionally, in I would say the last 5 to 10 years, focused on the handover process. We have some surveys that are quite interesting from the plant world. It highlights that even today, after perhaps what I would say 10 years of good initial development, in this area. Even the operators are not yet really happy with the information they get. And I think certainly in the marine world, we're still to go through this experience. There's some good examples of where this comes in. When I joined AVEVA 10 years ago, there was a really good project using AVEVA Net for the handover of information for an FPSO. It wasn't called the digital twin then, but this was using AVEVA Net. And the papers generated at the time highlighted that using traditional kind of what you call clerical methods, manual methods, people in an archive, they would perhaps collect 50% of the information and validate it by the time they got to first oil. But using AVEVA Net, they were close to 99% or so a year before first oil. And this was a very powerful message 10 years ago. So when I wrote the paper, I thought, well, I'll go back and find out what happened. And the information was very surprising. They found out that they were close to replacing the system. They didn't like it anymore. And I said, well, why? Well, they never maintained it. The system was originally designed or laid out for commissioning and installation. The strange thing was it takes a matter of days to reconfigure the system, but if you don't really embrace the digital twin, there's potential that you'll lose your initial investment. So, you know, it is more about a philosophy than just buying a system and making it, just having it there. A good example of a good philosophy, perhaps was seen more at last year's Marine Conference than the last kind of 6 months. One of our customers, Lundin, illustrated this with a philosophy that everything that could be done onshore should be done onshore. The idea of taking any work away from a safety-conscious environment. And there's a really good video on this. So if you want to have a look at the video, if you Google AVEVA Engage Lundin, you'll go and find this. I won't play the video today. So really what we want to do is go out and embrace the digital twin, go a little bit deeper into it. It gives us the ability to expose information on a range of different devices, be they miniature or very large, like the screen you'll see out there. Go out and embrace big data and the industrial Internet of Things. In fact, you've probably already been doing this, probably for the last 20 years. I mean, the condition monitoring is a very good example of how this kind of thing has been embraced on ships. But you can also use it in your day-to-day opportunities, say for planning maintenance, refit, and work packages. Last year, I took a surveying course. I was surprised to find out that surveyors rarely get any plans. They are happy if they get a GA. If they get a plan of some structure, they're really happy. But quite frequently, they're working with no plans at all. You could use it to support your staff through training or familiarization. Allow them to remove critical guesswork. I think I've talked today mainly about the style of AVEVA digital twins. There are also special digital twins that are coming along. This is another area where we've worked, is the condition monitoring of hull structure. The example here is where we've taken a file format called the OpenHCM, Open Hull Condition Monitoring, of models made in AVEVA Marine. And we can take the thickness measurements that are used and created in these files through into the different class systems. The examples here are Bureau Veritas, Veristar system at the top, and Pegasus system from DNVGL. So it's quite powerful how we can do other specialist digital twins. Something else I'm working with is with another customer. They're very much into VR. They're a naval customer, and they've just built some very large naval vessels. And in that case, they're having challenges with the crew on the vessel. When you have a very compartmentalized aircraft carrier, for example, what's there to stop the crew getting lost? How can they remember every compartment on the ship? So they're starting to think about how they could use kind of gamification, give every crew member a little game and ask them to find their way around the ship. And then through that process, link them onto more specific training examples, perhaps firefighting, or whatever they seem to do on naval ships. I'm not necessarily sure about that. So there's some quite powerful stuff that you can do with digital twins. So this kind of starts to draw the presentation to a close. Thinking back to some of my stuff that I did in my university days, I think one of the areas that is missing at the moment is very much on the decision support side. I think for the last 10 years we've been focused very much on the technology, but I remember when I was in my university days, we were much focused on trying to create decision support systems to assist crew. I think at that time we were missing the technology, and I now see a time for these two things to come back together, and I think that was also illustrated in the first presentation of the day. So to summarize the presentation, I think digitization is already happening. It's happening before our eyes, and sometimes we don't know it. I experienced that with my cycling. Really, I'm cycling on a bike that is perhaps become a full IoT system in itself. I didn't expect this to happen. Because our IT systems are often very important to us, sometimes to investigate some solutions, we need to think in a non-destructive way, and that comes down to the innovators in your companies. And beyond that, it's about adapting or adopting a digital twin philosophy. Go out and understand how the digital twin can work for you, how your IT works for you. So what it's about then is really an opportunity to innovate and understand how these systems can benefit you. And this is where I really bring in my colleagues, because they're all knowledgeable people with the systems that we work with. So it's not about necessarily investigating this on your own. Go and work with the people that are really understanding this system right now. So before I finish, if you'd like to know any more information, I'd like to highlight that you can find a demo version of AVEVA Engage on the Microsoft App Store. It's not just out there on the screen. You can find it and experience it yourself. And if you're interested in reading the paper that I wrote for SNAME last year, if you go to Google again and type in "taking control of the digital twin," it should have come up. But if it doesn't, try putting some quotes around the text, because that should produce a more contextual search. Thank you very much.